So today we will talk about fuzzy logic and uh, fuzzy systems, fuzzy logic and fuzzy system. Now the lecture consists of what is fuzzy logic, what are fuzzy sets, membership function, difference between fuzzy and probability, fuzzy inference, and why we use fuzzy logic. So today is a marathon lecture. Marathon lecture means that it will be somewhat lengthy lecture. What is fuzzy logic? Fuzzy logic membership is a matter of degree. Fuzzy sets versus classical set theory. Founder of fuzzy logic is Zade, and fuzzy reflects how people think, attempts to model our sense of words, decision making and common sense mathematical principles of knowledge representation by degree of the membership rather than crisp membership of classical theories. For example, just a simple example, if we have, let's suppose, a line, this line, and line 1, line 2 and line 3. So we can say that this line 1 is short, this line is long, second line, third line is very long. So actually what this means, what short means, what long means, what very long means. So fuzzy logic gives a mathematical shape to these terms: short, long, very long, and so on. It will be clear from the coming examples. So here is an example, and this example, yes, here is an example. We have certain names of people mentioning their heights, and we have degree of membership functions. So it is fuzzy membership function and crisp function. What it means? In the crisp function, we divide the heights of these people into two halves. One is, we can say that the height is very high, and second half we can say that the height is short. So the people which has a height equal to height less than 180 will be short people, and having the height greater than 80 will be tall people. So the fuzzy divide this membership into a meaningful way, that for example if we say that a person having 150 centimeters or 2 centimeter is short, and then it is gradually increasing, and after 180 centimeters we can say that the person is having more height, and below 80 we divide that value into different values. For example, if we say that A person having more than 200 centimeter height is long or tall, so and having 152 centimeters height is short, then the rest of these values we categorize that uh, into a membership, into a membership. We don't call it as a either it is tall or short. So let me give you another example. For example, we have a car moving, let's suppose, with some speed, and we suggest that a car, if it is moving with a speed 50 miles per hour, greater than a speed greater than 50 miles per hour, is running fast, and less than 50 miles per hour is running slow. So the car, when at 49.9, it will run according to our assumption, it will run as slow, and a car at 50.1 will run, we say it is at a high speed. So for example, if we used fuzzy logic and application fuzzy logic in the smart vehicles, so if the condition is, if a car is running slow, so it has to apply accelerator to speed up its motion or its speed, to increase its speed. When it reaches 49.9, it will increase, it will yet increase its speed and push the accelerator. When it reaches at 50.1 miles per hour, so the condition here is that it should apply brakes. So after for example 0, we can say 0.2 miles, which the car achieves in a very short time. So in this time it will apply brakes, and then when the speed becomes less than 50, means 49.9, so it will accelerate again the car, and so the passengers will feel a lot of jerks and so on. So the fuzzy logic, what fuzzy logic do, it divides it into a region. For example, that the car from here, let's suppose we say 30 miles per hour, and here we say 70 miles per hour. So from 30 miles per hour, it is slow, and its speed is increasing, and this area is divided into whether the speed is gradually increasing, and if it is more than 70, so it we can say that the speed of the vehicle or the car is very high, and it has to apply the brakes. So the fuzzy logic change the certain change of value into into a range of values where the decision will be easy for the system about the values. So this is what how we can define the fuzzy logic and membership function, degree of the membership. So this is the degree of the membership. Now if mathematically we see the function, for example the crisp set representation will be either 0 or 1, means it will be true or false, while fuzzy sets we have an extreme equal to 0 and minimum extreme is equal to 1 and minimum is equal to 0, and there will be values between 0 and 1, so having different membership functions. These are different membership functions. So here we will explain one of the membership function, that is triangular function. It is called trim function, and the parameter for this trim function is 3 values, 3, 6, 8. What this means, that the change in the membership function, or the change in values slowly and gradually starts from 3 to 8. This position will 8, this is 3, and the mid position is 6. So slowly the values are slowly and gradually it changes, and so on. So how we can represent that? For example, if we say that 3 is equal to, let's suppose, 30 miles, and this is slow, and 8 is equal to if we suppose that the car is running with 80 miles per hour, so this is the highest speed we can say. So the degree of membership is from 30 to 80. So 30 we can say it is very slow, and 80 we can say it is a fast, and in between the values, those values we call it degree of a function. So here, for example, so we associate the actions with the different functions or different values. For example, if we can say that a car is running at 45 unit, so this is not too much speedy. So when there is an obstacle or something, so the car and that obstacle is far away from the car, so it will apply brakes mildly. If the car is moving at 79 miles per hour, and there is an obstacle, so we can say that the car is moving very fast, so it will apply strong brakes. So we associate an action with the degree of a function. Hopefully you will understand till this point. Now the difference between fuzzy versus probability. Fuzzy is actually not a probability, is not equal to a probability. The probability deals with the uncertainty or likelihood. For example, and the fuzzy deals with the ambiguity and vagueness of the terminologies or of the values. So it is here with this example it will be clear. For example, a bottle consists of water. If we say that 50% probability of being poisonous, means 50, if we say that there is a probability, 50% probability that the water is poisonous, so it means that whether there is a chance, half chance that the water may be poisonous or may not be poisonous. One will be true, either it will be poisonous or it will not be poisonous. There is a 50% chance, while a 50% fuzzy membership of poisonous means that the water is half poisonous. So this is this is the probability. We deal with a chance, while fuzzy logic that value or the value or that characteristics we associate with the object that actually exist up to some extent. No, there are different operations when we use fuzzy logics. So for example, if we have a function a starting from this point to this point and so on, and function b is starting from this point to this point, and we are these two functions, so it will include the covered area, or we can say the values which is covered by both a and b, and function we have which are the common values of a and b, and component means those values which are not included in the set of a or b. So these are the operations which we will do, we can do in fuzzy logics. So here we will define linguistics variables and hedges. So for example, if we say that wind is a little strong, so what is wind, what is little, what is strong? Or weather is quite cold. So wind, weather, height, weight are linguistic variables. This is a linguistic variable, and for that linguistic variable strong is a linguistic value, and these are the we can say these are called hedges. So hopefully you will understand these terminologies. Now we will discuss fuzzy inference. Fuzzy inference is the process of formulating the mapping from given inputs and outputs, and we use different rules. For example, if we say if the distance to the intersection is far and the speed is slow, apply gentle brakes. So hence here we have the values, conditions, values, and to those values we have an associated an action, and so on. So you just read out all these rules and the actions associated to those rules. Fuzzy inference. Now assume we want to evaluate the health of a person based on his height and weight. The input variables are the crisp numbers of person, height and weight. Output is percentage of healthiness. Now for example, if we have this function, one function is weight, the other function is height. These are the inputs. So we can say that the height of a person, if it is very slim, medium, heavy, very heavy, and so on, and height is very short, that is from 1 to 140 centimeters, Then from 140 to 160 centimeters is, we can say it is short, and then so on. No Step 2, rules reflects expert decision. Rules are tabulated as fuzzy words. Rules can be grouped in the subset. Rules can be redundant. Rules can be adjusted to match desired values. So here are so we have these two are inputs, and here we have an output. So output will be, we have h means that the person is healthy. Its value depends upon the height and weight of the person. Somewhat healthy, less healthy, unhealthy, and these are rule of functions UHL. We have defined that. No For example, if a person is very short and very slim, so it is that person is healthy, and so on. If a person is very short and very heavy, then we can say that it is unhealthy. So these are the rules, the membership functions. For example, if we divide these functions uh, into values, no here uh, for a given person, compute the membership of his her weight and height. Assume that the person height is 180 centimeters, and assume that the person weight is 49 kg. So here 49 kg. At this point we have 49 kg, this line showing, and means that the membership function of slim is equal to 0.2, and the membership function of very slim is equal to 0.8. So here we have membership function of very slim 2 and slim 0.2 and 0.2 for the slim, and the height is 185 centimeters here. So the values are 0.7 for medium and 0.3 for the tall. So 0.80. So here, and the height is 0.7 and 3, so it falls under can fall under this category. So let me show you here. If we have these values, 0.8 very slim, and 0.7 is the height is medium, then the person will be healthy. And if a person is short and 0.2 person short and 0.3 person tall, so that person will not be too much healthy, somehow healthy. This is somehow it will be healthy, and it will be little healthy. if 0.8% it is short, sorry, uh, so here this is min operation. Min operation means that, for example, one value is 0.8, another value is 0.7, so the minimum value is 0.7, and here one value is 3 and the other value is 2, so the minimum value is equal to 0.2. so this is how we will take the values. Now we will proceed further. This is the scale decision. 0.3 is unhealthy, 0.7 is little healthy, 0.2 is somehow healthy, and 0.2 persons among them are healthy. Defuzzification. Defuzzification means that we have to find a point which we call it centroid point, where the membership function is 100%. So defuzzification is the somewhat the center of the scale. Here we have crisp decision index is equal to d is equal to 0.4421. This is decision index, where 75% in less healthy group and 25% in somewhat healthy group. So this is all about fuzzy logic. Now we will go and we'll implement this example with fuzzy logics. So for that you should need Matlab, and I have a Matlab. I will open Matlab. Yes, here I have Matlab. So I will open Matlab. It will take some time. Now the Matlab has been opened, so I will here type fuzzy, and it will open fuzzy tool in Matlab, where we will implement an example. This is a fuzzy tool, and we are going to implement the example. Build a fuzzy system. So it consists fuzzy logic design. All this is called fuzzy inference system, rule editor, membership function editor, and then we have rule viewer, and we have surface viewer. Here the problem is that we are solving this example. The example is that we have a service of a restaurant where the food has to be served. Food may be poor, good, excellent, yes, and then a tip will be given, depends upon the food and also depends upon the service. So here are the these are the inputs and outputs, and in input terms there will be rules and input rules, uh, and so on. So these are the rules. If the service is poor or food is rancid, then the tip is cheap. If the service is good, then tip is average. If the service is excellent or food is delicious, then the tip is generous. Assume that the average tip is 15% and a generous tip is 25% and the cheap tip is 5%. So this will be the tip from let's suppose 0.5 to 0.25. Now here we have got we will go to the Matlab. We have got this function. This is Memdani. It's a type of function which gives some values or variations. For example, from let's suppose we can say from 0 to some other value. So here we have to take the input. So for this specific example, we will have two inputs. One is service and the other is food. So here we have input 1. Here we have one input, and we will change this input name into service. So here so this has been changed into service. Now we will so here we will add new variable. So add new input variable. So we have two input variables, and here we will give a name food, and the output variable we will name as tip. So and this we will name as we will name it as a tipper. So here we can change the name of the function file, and then to export to workspace, and here we have to change the name into tipper. So that is has been changed. Now we will give the inputs by double clicking on the service. Now we will be able to give the inputs. These are the membership functions: mf1 membership function 1, mf2 membership function 2, and mf3 membership function 3. So here by default is use trim function. So we will change that function from trim to the function Gaussian function. So here we will select it. There are several ways. For example, you can remove all the ms function here, and then you add custom functions, like for example first custom function should be poor, and the name of that function will be okay. Okay, so just a minute. We have to add uh, uh, okay, we have to add mf. By default we have to add Gaussian function, and the number are 3. So here we have mf1. Now we will name it first poor, second one is good, and third one is excellent. So here we have to give excellent. So these are three input membership functions. Now we will close it. So for food, no, here we have close it. No, for food we have to choose functions according to the functions in the example. So that is for service, and food we will use again two functions. mf1 we will use this Gaussian, and that will be the function will be rancid, and third one we will remove this, remove selected one, and this one we have to name it delicious, and it will be Gaussian, and we have to move it here. So the range, you can change the range from 1 to any value. You can also change the display range. So we will see what range they have used for the different membership functions. So first of all we will see the membership function of service. So the membership function of service for poor we have parameters, and these parameters are we can say it 1.50. so it will be 1.5 and 0. So this is the parameter for poor. Now here we will change the range so that we can see this value where it ends, and we will see the range for it. So the range for this is 0 to 10, so we will have to change the range from 0 to 10, and the display range will also be changed. So again, this is service, and we have, so here it is 1.5 and 0. Now it will be looking good, and for good the parameter is from 1.5 to 5, so it will be, we will give it number from 1.5 to 5, so it will exactly look like this. And for the excellent we will give from 1.5 to 5. So these are the ranges for the poor, for good and excellent. Now food, we have two parameter membership functions. One is rancid and the other one is delicious, and we will see the here the membership function and the value. So here we have the range from 0013, so they did not use the Gaussian function for this, but they have used trapezoidal function for this, so we will change it into trapezoidal function. Okay, and this one into trapezoidal function. So trapezoidal function, we have 4 values, we have to enter 4 values, and also we will see the range of the display. So the range of the display is again here maybe from 0 to 10. Okay, it will be from 0 to 10. Range is from 0 to 10, and the display range will change automatically. So here we will give the values manually, and that is 0, 0, 1 and 3. And for delicious, how much we have to give the values. If desired, for example, for delicious we have to give, let's suppose, 3 and 4 and 8 and 10. So this will be for delicious. So we have given the values. These two are inputs, and now for the output we will have cheap output will we will have one membership function cheap, second membership function average, and third membership as a generous. So here we have to define this function first. mf1 is first one is cheap, uh, and same trim function will be used, uh, and second one is average, third one is generous, and we will use the range from 0 to 30, and now we have to give the range. It will be range, three values of range, for example 0, 5 and 10. So it means that it will start from 0, its peak will be at 5, and it will be goes down at 10, and so on. So I have stopped the recording during the azan, and I have initiated all the values for cheap, average and generous. Now we will add rules for the what we have entered into what we have entered into the fuzzy system. So here we will open the rule editor, rules, and then we have to open the rules. So here we have a rule editor of tipper. So if the service is poor or rancid, then the tip is cheap. So we will add this rule, add this rule here, it will be added. Second rule is if service is good, then tip is average. If service is good and the tip is average, add rule. We have only one parameter. And if service is excellent or food is delicious, then tip is generous. If these two rules and the tip is generous, so add this rule. So we have added these two rules. Now here we have these rules. For example, it can be changed, these services can be changed, so depends upon these two. For example, this if the service is low and the food is not delicious, then the tip is very much low. And if food is good, service is not good, then it is somehow average. And if both are good, then we have very high tip. So this is the fuzzy logic. And if we see the graph for it, it will take some time. So this is the graph for it. For example, if we have service, If we have service and tip, so when the service is very good, the tip will be increasing. And for food, if we have, let's suppose, food, so it will have the this type of uh, a type of graph. Now this is the 3D graph, and you can see the food, service and tip. Here we have tip maximum if service is good and food is good, and this value where food is good but service is not good, so that's why we have low tip. So that is all. See you next time. Thanks.